Ladies and gentlemen of geometry, we're looking at 9-6. Kind of everything and anything having to do with spheres. So that's kind of what we're looking at. Figuring out the surface area of spheres and figuring out the volume of spheres. Spheres kind of play by their own rules, okay? They kind of do things a little bit differently than any other shape we've encountered thus far. So let's take a look and see what we're doing. So kind of the rules of a sphere somewhat follow the same rules as a circle, okay? You've got a chord, you've got a diameter, you've got tangent, you've got plane that intersects the circle at the center. So this is your segment from the center to the point of the sphere. So this is your radius, segment that connects any 2 points. There's your chord, a chord that contains the center. There's your diameter. Endpoints of the diameter of a great circle is called your poles, and a plane that intersects the circle at center is called your great circle. So playing a little connect the dots, that's kind of what each one does. So a couple of familiar terms, although they get a little expanded, and then a couple of new terms over here called the poles and the great circle. So it's kind of, here's what we're looking at. Surface area of a sphere kind of becomes one thing. Basically, you're going to take pi r squared, all right, which is the area of a circle. But what you got to realize, though, is that if you look at a circle, if you look at a sphere from 4 different directions, you're going to see all of the sphere. All right, so all you end up doing is take 4 times pi r squared. Okay, volume is a little bit different. Volume is, you're going to take 4/3 pi r cubed. So, big difference. Surface area squared, volume cubed. That's kind of what you're looking at. So find the surface area of the sphere. Radius is 6, so that's 4 pi r squared. So that's going to be 4 pi times 36. 36 times 4 is going to be 144 pi centimeters squared. And remember, that's exact. Then you multiply that times pi, and you get 452.389. And that's going to be your approximate, okay? So keep that in mind. Exact approximate depends on what the question's at. Surface area. Well, diameter is 22, so that means the radius is going to be 11 feet. So that's going to be 4 pi 11 squared. So what you're doing is you're going to take 484 pi, and when I multiply all that out, and that is going to be your surface area. And again, that is exact. So I multiply by pi, I get 1520.53 feet squared. Okay, and again, that's your approximation. That's not your exact answer. All right, find the surface area. The circumference is 5 pi. So circumference, remember, is diameter. Is diameter times pi. 5 pi. So your diameter is going to be 5. So that means your radius is going to be 2.5. So radius is 2.5. So you're going to go 4 pi 2.5 squared. So 2.5 squared times 4, you're going to end up with 25 pi. All right. So that's going to be your answer in meters squared. So multiply by pi. That's going to be 78.5398 meters squared. Again, exact, approximate. You're guessing. All right, surface area, if the great circle is approximately 130 inches squared. So your area is there. So pi r squared is about 130 inches. So you're going to divide by pi. So take 130 divided by pi. And then you're going to take the square root of that. So when you do that, I get my radius to be 6.43275. I'm trying to be as exact as I can here. So then when I go 4 pi r squared for my surface area, I'm just going to turn around and square that. I'm going to multiply it by 4. So when I do that, I get 165.521 pi inches squared. and then if I multiply it by pi, it ends up being 520 inches squared. So this is actually weird because this is the exact answer and this is the approximation. All right, which is weird because it actually worked out to be a whole number. All right, jumping gears, volume with a great circle circumference of 18 pi. So now we're switching gears, going to volume. All right, so circumference is equal to 18 pi. Circumference is going to be double the radius times pi, or diameter times pi. So little math, little algebra, 18 equals 2r, so my radius equals 9. So now volume is 4/3 pi r cubed. So I want to take 9 cubed times 4/3. So I'm going to take 4/3, 9 cubed. And when I do that, that's going to be 972 pi centimeters cubed. And remember, this is exact. So when I take 972 times pi, I get a really, really big number, like 3,053.63 centimeters cubed. There is my answer right there. So 4/3 pi r, so you got to be clever here. So surface area of a hemisphere, volume of a hemisphere, it ends up being just half. So instead of 4 pi r squared, you end up dividing it by 2, so you end up with 2 pi r squared. 4/3 pi r cubed. So ends up being, if I multiply that times 1/2, this becomes 4/6. So that becomes 2/3 pi r cubed. So basically, you're just taking your previous ones and dividing it by 2. So surface area here, so that's going to be 2 pi r squared. So I'm going to take 2.8 squared. 2.8 squared times 2. So that's going to be 15.68 pi centimeters squared. And that's your exact. So when I multiply it by pi, I get 49.26 roughly. There's my answer. So half of that. So volume of the hemisphere, so a radius of 6. So remember this, 2/3 pi r cubed now. So it's 2/3 pi 6 to the third. So 6 to the third times 2/3. And that's going to be 144 pi meters cubed. Okay, so now that's your exact answer. So take that times pi, and you'll get 452.389 meters cubed. So the stone spheres of Costa Rica were formed by forming, I don't know what that word is, boulders into spheres. One of the stone spheres has a volume of about that. What is the diameter of that stone sphere? So you've got this diameter of 113,097.34 cubic inches. Now that equals 4/3 pi r cubed. So that's step one is going to be multiply this by 3/4, because that will cancel that out. So multiply this by 3/4. So 113,097.34 times 3/4. So I get 84,823 equals pi r cubed. So then I'm going to divide that by pi. And when I do that, I get 27,000 equals r cubed. So now to do this, I'm actually going to take the cube root, the third root of 27,000. So in a calculator, I basically raise it to the 1 divided by 3. So that's kind of like saying, take in your calculator, take 27,000 and raise it to the 1/3 power. That's how you take a cube root. And I get an answer of 30. But now that's my radius. They want diameter. So I'm going to multiply that by 2, and I'm going to get 60 inches across. So that's 5 feet across for that thing. All right, surface area and the volume of your favorite planet. You're given the radius in miles. So pick one. and then figure out the surface area and volume of, there's your radius. Yes, we included Pluto because Pluto is technically, in my eyes, still a planet. Come talk to me with questions, and we'll see you soon.